Hello guys, welcome to our class for today. We are we are going to be looking at calculations involving rectilinear motion. Remember that in our last class we discussed the three equations of motion. So for this particular class we'll be solving some problems using those equations that we just derived. So please, I want you to get your writing materials, get your calculators so that we see how we can apply those equations that we derived in this particular lecture. So please get your writing materials ready. And also, if you have not subscribed to this channel, please, what are you waiting for? Please subscribe to this channel. Click on the notification button so that whenever we upload a new video, YouTube will notify you. Also, please put your comments on the comment section below. Give us a thumbs up. You can also reach us through the WhatsApp number that is showing on your screen so that we can always discuss with you and see how we can help you in your various physics problems. Alright, so I remain Otobo Michael and then you are welcome to this class for today. Alright, so we are going straight to calculations involving rectilinear motion using the three equations of motion that we derived in our previous classes. Okay, so we have different questions that we want to solve. So we're starting with the first equation. This is the first question. Okay, so for this particular question, it says draw the velocity time graph for a body which starts with an initial velocity of 4 meters per second and continues to move with an acceleration of 1.5 meters per second squared for 6 seconds. Show from the graph how to find 1. The average velocity, and 2. The distance covered in 6 seconds. Alright, so for this type of problem, you are given that initial velocity u is equal to 4 meters per seconds. You are also given that acceleration is equal to 1.5 meters per second squared, and then time is given to be, for the acceleration is given to be, time for the acceleration is given to be 6 seconds. So here you are asked to draw the graph. You are asked to draw the graph of this motion. So we're going to draw the graph. Please don't mind my graph. You draw your own and let your own be very straight, right? Okay, so I will try to make my own to be as straight as possible. Okay, so this is your graph, this is your origin, and this is your velocity as this, and then this is your time as this, right? Okay, so the body starts from 4 meters per second, so we are not going to start from rest. The body did not start from rest. It did not start from 0, so it started from 4 meters per second. So assuming that is 4 meters per second, it now accelerated up to this point. You can see that. So this is 4 meters. Can do that then. Okay, so that then said in time 6 seconds. Okay, so we can say this is 6 seconds. The time 6 seconds. Okay, so it started from here and it got to this velocity, which we don't know. We don't know this velocity, so we're going to look for that. Okay, so this is how your graph should look like. Please try and draw your graph to be as straight as possible. This time is seconds. This time is seconds. So you can draw it and then label your graph properly. Please make sure your graph is well labeled. Fine. Okay, so this is the graph that you are supposed to have for this particular question. So this is how your graph should look like. Now we want to solve, say from the graph, show from the graph how to find 1, the average velocity. Okay, so before you can find the average velocity, you must first of all find the final velocity. So if you're looking at what you are given here, you are given initial velocity, you are given acceleration, and then you are given time. So which of the equations of motion are you going to apply? if for you to get the final velocity, you see that you need to apply the first equation of motion. So the first equation of motion says v is equals to u plus at. Alright, so substitute into this equation. You had that v will be equals to 4, which is your initial velocity, plus 1.5 multiplied by 6. Okay, so that gives us 4 plus 9.0. So your v will be equals to what? If you add up this, you have 13.0 meters per second. So this gives you your final velocity. V is your final velocity. That okay? So that will be the final velocity for this particular motion. So your v2 here will now be 13.0. Okay, so this 13 point, this is 4 meters per second. This is the initial velocity, so 4 meters. Okay, so that is 4 meters per second, and then this one is 13.0 meters per second. Okay, so we've gotten that now. We've gotten this. So the next thing I'm going to do now is to find the average velocity. The next thing we're going to do is to find the average velocity. So for us to get the average velocity for this particular motion, what we're going to do is use the equation that we had before. We are told that average velocity is equal to what? Initial velocity plus final velocity, or final velocity plus initial velocity, that is v2 plus u all over 2. So that gives us 13 plus 4 all over 2, and that will give us 17 all over 2. So when you do this division, you are going to have that average velocity equals to what? 8.5 meters. Okay, so this is your average velocity. So the first part of this question has been solved. Average velocity, which is this, has been solved. The next part is the distance covered in 6 seconds. Distance covered in 6 seconds. We know that distance from the equations we got, we know that distance covered equals to what? Average velocity times time. So substitute to this equation, you are going to have 8.5 times 6. So when you work this out, what you get? You work this out, you have 51.0 meters. Okay, you have 51.0 meters. So this gives you the distance covered for this particular motion for 6 seconds. This is the distance covered. Okay, so this you can also get it if you look at this graph. You see that this shape is that of a trapezium. So if this is the shape of a trapezium, these are the parallel sides, and then this is the height of the trapezium. So you can also use that to solve it. You can get it that, and the area of the trapezium is half sum of parallel side times height. So the sum of the parallel side, you have so distance is equals to, for trapezium, is equals to half. We give you half. Parallel side is 4 plus 13, okay, times the height, which is 6. So if you look at them, you see that the equations are the same. So you have half 17, half 17 times 6. So that also gives you 8.5 times 6. So when you multiply that, you also have the same answer, which is 51.0 meters. So whichever way, this from the graph, you can use this to get this, and also with this formula, you can also get the same answer. So this is how to solve this type of problem. So see how we started it and how we were able to get our final answers. Is that okay? So I hope this one is simple, and then you can follow through with this. All right, so that is what we have for that. Okay, so that is it. This is another question. A body moving at an initial velocity of 30 meters per second accelerates uniformly at the rate of 10 meters per second square until it attains a velocity of 50 meters per second. Calculate the distance covered within the period. Okay, so if you look at this question, you see that you are giving initial velocity u to be equal to 30 meters per second. Okay, you are giving a final velocity v to be equals to 50 meters per second, and you are giving acceleration to be equal to 10 meters per second squared. Now looking at what you are given, which equation of motion applies for you to find the distance? You see that it is the third equation of motion that will apply. So the third equation of motion says v squared is equal to what? U squared plus 2as. That's the third equation of motion. So if you make s the subject of a formula, you have that s will be equals to what? It will be equals to v squared minus u squared all over 2a. So if you substitute into this equation, you have 50 squared minus 30 squared all over 2 times your a, all over 2 times 10, all over 2 times 10. So multiply this out, you are going to have 2500 minus 900 all over what? All over 20. So if you work this out with your calculators, you will have that your final answer will be equals to what? 80 meters. So this will be your final answer. So you can see that this one is straightforward. The important point here is for you to know which equation applies, and for you to know, you must know the variables that are given to you. Once you know the variables that are given to you, you will be able to know which of the equations to apply for you to get your answers easily. These are actually objective questions, so and you know that in objective you don't need to waste too much time, so you save time for other questions. So this is the solution for this particular problem. All right, so we are going to solve other ones so that we'll still drive home the how to use the formulas. Okay, fine. So this is another question. This one says an aeroplane initially at rest undergoes a constant acceleration of 2.5 meters per second square down the runway for 30 seconds before it lifts off. How far does it travel down the runway before taking off? Okay, so if you read this question very well, you understand, you see that you are giving acceleration, you are giving time. They said that the aeroplane starts from rest. So if you start from rest, it means that the initial velocity is equals to what? 0. So if you are giving time and acceleration, which equation of motion applies? If you look at the equations very well, you see that the second equation of motion applies. So let's go. So here you are giving that A is equals to 2.5 meters per second squared, and then you also give it that T equals to what? 30 seconds, and that U, since the body starts from rest, U is equals to 0. So from the second equation of motion, we have that S, which is distance traveled, is equals to what? Ut plus half AT squared. Now, since U is equals to 0, it means that this part of the equation is equals to 0. So your S will now be equals to what? Half AT squared. So substitute into this equation. If you substitute into this equation, you're going to have what? You have half times 2.5 times 30 multiplied by 30. Okay, so if you point this out, this divided, you have 15. So if you point this out in your calculator, you have that the distance traveled will be equals to what? 1,125 meters. Okay, so from your calculator, this is what you have: 1,125 meters as the distance traveled. So you see that once you know the equation to apply, normally you are not even supposed to waste time. Yes, just know the equation to apply. Your answer will just come readily in a jiffy. You get your answer to your questions. Is that okay? I hope that is clear and that is understood. Okay, so I want to solve another problem now too. See, I love to solve problems so that you can understand how to apply the questions as they come. Right? The more problems you solve, the better for you. It will help you in understanding. Okay, so let's look at this question now. This is another question. This one is very interesting. It says that a bus driver moving at a velocity of 100 kilometers per hour suddenly sights a goat crossing the highway 49 meters ahead. He then applies his brakes to get a maximum retardation of 8.0 meters per second squared. How far will he go before stopping? Will he hit the goat? So you are asked to calculate the distance that will travel before it will stop after the brakes are applied, and also to know if the bus driver will hit the goat that is standing 49 meters ahead. So if you look at this question, you see that you are giving an initial velocity of motion to be 100 kilometers per hour, and then you are not giving the final velocity, but you are giving the retardation. Right, you are giving the retardation. So with this, which of the equation apply? Time is not given here. So as far as time is not given and you are looking for distance, then the third equation of motion does what? Applies. The third equation of motion applies. But before you do that, you must convert this to meters per second. So that's what we're going to start with now. Okay, so we are giving that U, which is initial velocity, is given to you to be what? 100 kilometers 100 kilometers per hour. Alright, so converting this now to meters per second, you have 100 times 1000. We've done all this conversion before in our previous videos, so you can just go there and get that, right? All over 3600. Can check our previous videos, you see how we did all that. Okay, so I will encourage you to know how to do some of your unit conversion. Okay, so this is how you do that. So you have, when you do that conversion, you do this, punch this one in your calculator, you are going to have 27.8 meters per seconds. Alright, so this will be your velocity, which is 100 kilometers per hour is equals to this in meters per second. Alright, so this is your initial velocity, u. Now, for you to find the distance traveled, as I've said before, you are going to use the third equation of motion, since you are giving retardation to be equals to 8.0 meters per seconds squared. So from v squared equals to u squared plus 2as, you have that s will be equals to you have s will be equals to v squared minus u squared all over what 2a. So since v is equals to 0, so you have minus 27.8 times minus 27.8 as u squared all over 2 times what? All over 2 times 8. Right? Okay. So if you punch this out from your calculator and you do your normal division, you are going to have 48. I'm going to have 48.3 meters. This will be your final answer. So if you look at this, you see that the goat is standing at, the position of the goat is what? 49 meters. This is the position of the goat, 49 meters. And the car will stop at 48.3 meters. Right, so the distance between the goat and where the car will stop is the difference between these two distances. Is the difference between the two distances. So when you find that difference, you have that, you have 49. You have 49 minus 48.3. So if you do that, you have 0.7 meters. So which means the bus is going to stop 0.7 meters from the goat, and because of that, it means that the bus will not hit the goat. So the bus will not hit the goat. Is that okay? The bus will not hit the goat because it will stop at 0.7 meters before the goat. So the bus is not going to hit the goat. I hope this is clear. So this is how to apply some of the equations of motion. This is how to apply some of the equations of motion. Alright. Okay, so this is your test, your understanding page. Please try and solve these questions. Apply the equations the way we apply them in our own examples that we just solved. Right? If you have any challenge, put your comments on the comment section below. You can also reach me through the WhatsApp number that is shown on the screen. That okay? So that is where we are stopping for this class for today. Thank you so much for your time. If you have not subscribed to this channel, please, what are you waiting for? Subscribe to this channel, click on the notification button, and then give us a like and a thumbs up. See, we have a lot to do, and we are dishing out a whole lot of informations to you guys. We'll be gathering momentum gradually, and now we are actually progressing to higher topics in physics. So please just give us a like, give us a comment, invite your friends to come and join this wonderful channel so that you all can benefit from it. So thank you so much. We see you in our next class.